Hello again. I see that the trickle of attendees showing up has seems to have slowed, so I think we'll go ahead and get started. First of all, thanks for joining us for our webinar here today on why zero trust needs to be implemented at the data or file level. To go over some logistics, we'll be handling any questions during the webinar through the Zoom webinar question interface. So you should be able to type out any questions and we'll either answer them during the course of the webinar or at the end, we'll have a dedicated Q&A section. You should be able to see the button for asking any questions at the bottom of the Zoom webinar application. Also, this webinar is being recorded and we will make it available online as soon as we finish the post-processing afterwards. We'll send out a link to everybody who registered for this webinar, and you can share this with anyone that you think would find it useful. Just to cover what we're going to go over today, we're going to do an introduction of who we are, who will be speaking today, go over a quick overview of zero trust principles and the importance of taking a data-centric approach to data security. Then we'll dive into the meat of the content for this webinar, which is really like how zero trust is implemented at the file or data level. Talk about some of the differences between the concepts of granting access versus granting ownership and what that means. And then we'll have some time to talk about both NextLabs and Anchor's solutions for data-centric security, specifically as it applies to applying zero trust at the file level. And we have some demos, some prepared demos to share with you as well. And we'll finally save some time at the end for some questions and answers. So going into who we are. So my name is Tony Burning. I'm a senior product manager here at NextLabs. And today I have the pleasure of being joined by Emre Koksal, who's the founder and CEO at Anchor. Emre, do you want to give a brief introduction?
Sure. Yeah, thanks. Again, as Tony, thank you for having me over here. And, Emre Koksal, I'm founder of Anchor. Before Anchor, I was mostly in academia. I was at MIT first in EECS. And after that, and I am still a professor of computer engineering at The Ohio State University. So happy to be here.
No, thanks, Emre. Thanks for joining us. I think that really looking forward to this. Mm-hmm. So with that, I think we're going to go ahead and jump into the content. I will actually turn off my video just to not be a distraction. So first, going over what is zero trust, what is zero trust architecture. This is something that NIST, the National Institute of Standards and Technology, has adopted as a recommendation. But zero trust architecture, there's really 5 main principles to go over. First is that all protected resources are accessed in a secure manner, regardless of the location. So regardless of whether they're inside or outside of a secure network, all access and authorization is granted on a least privilege principle. And only on a need-to-know basis. So you're not providing anything more than the minimum of what needs to be accessed. Third principle is really always verify and never trust. This is where the name zero trust comes from. So regardless of whether somebody has already authenticated with the network or like to access the resources, you still never trust. Always verify that they are able to access the resource. And then the fourth principle is to always inspect, log all traffic, so that you can use that to make sure that there is nothing that's being compromised. And then finally, the fifth principle is designing a network or secure resources like from the inside out. So instead of protecting the perimeter, you're assuming that threats can originate from either inside or outside of a secure network. And so you always need to be trusting or verifying that a user or system has the appropriate authority to access a controlled resource. So with how this relates to data-centric security, So data-centric security is focused on protecting data wherever it resides. So instead of protecting the network or the system that the data might be on, it's really focusing on protecting the data itself. And that means that the protection also follows the data wherever it goes, whether it's like being stored in a database, being used in an application, or it's being shared through files. So this is zero trust architecture and other zero trust data protection is an implementation of data-centric security that requires that you validate the authorization of the user to access the data every time it is accessed, regardless of whether the request is coming from inside or outside of the network. So that's really the principle, is that zero trust is an implementation of data-centric security. So in terms of implementing this, we have a attribute driven dynamic authorization policy engine. So what that means is when we say it's attribute driven, that means that data access policies would be defined in terms of the attributes of the user, the data that they're accessing, as well as the context or the environment in which they're making that request. So, so we have some examples here in the diagram. So user might be, what business unit they're part of. It could be what some of their assigned roles are. It could be their location or anything else. The context being like what network they're operating for, what IP address, what time of day, what geographic area, and then the attributes of the resource itself could be what type of data it is, whether it's controlled, whether it's governed by any regulations, or the content of the data. So taking all those attributes, combining them together into a single policy, and then dynamically evaluating and enforcing that policy at the time of data access is really what we're talking about here. We're talking about attribute-driven dynamic authorization policy engines. So this then these policies are then evaluated at the time of the access request to make sure that they're always accurate and up to date. So an example of this here, where we're combining the subject attributes. So we're talking about the title of the user, as well as the like whether they've completed training as specific attributes. Combining that with the environmental attributes, so like checking to see that this is a work hours, this request is happening during work hours. The resource attributes being that it's customer data, and then limiting the actions that the user is able to perform based on how the policy evaluates. So this is more examples. So we can end up with allowing a CSR working in the M line of business in Region X who has completed VIP training to access the VIP customer data, but only during the work hours and only performing the actions that are specified, which may be, say, view and edit, but not create or delete, for instance. So this is a more concrete example of what a dynamic authorization policy may look like. So so now I'm going to turn it over to Emre.
So thanks much. I really enjoyed the connections you have made with the attribute-based access controls. To emphasize a few of the points you have made, let me quickly take a step back and explain the progression of zero trust from a defense in depth style of point of view. As you mentioned, the zero trust paradigm removes the notion of perimeter to protect the data or the infrastructure, right? So zero trust assumes any request to access the network, application, storage, or the data is not trusted, regardless of where it's originated from, and verifies the legitimacy of the request before granting access. So the idea here is that the request might be generated by an attacker who made their way inside the traditional perimeter. Even in that case, you need to protect your infrastructure. So earlier approaches to zero trust were based on this motivation. So these early architectures were constructed around network or application controls. Namely, the assumption was that the attacker successfully breached to your network and also is capable of creating processes from your applications. Even in that case, should you be able to protect your data that is within your network and accessed by your applications, in that case from the successful attacker. So the new approach to zero trust actually takes this a step further. It starts by asking the question, since the ultimate goal is to protect the data, which is your most valuable asset, why don't we focus on the data directly? Why focus on protecting other assets all in the name of protecting your data? So in zero trust down to a file or data, the protection is baked directly into the data, as you have mentioned. Namely, even when your data is accessed, shared, or even stolen, it remains secure. Simply put, wherever the data goes, even outside of the scope of its owner, your data is protected. Zero trust push to file integrates security in a way that the data protects itself. In a sense, data becomes its own security boundary encapsulated in the file, if the data is the file. Once it happens, it frees the user up. As protection and control travels with the data, wherever data goes, it's protected. And hence, the perimeter is eliminated. Not only that, you can give access to data and collaborate without imposing any change in the applications you use or the way you store or share the data. In fact, I'm going to show my demonstration in a few minutes to show and illustrate all these points. So with this data-centric approach to zero trust, you don't add friction to business or change any of the workflows. You align security with the business. It's not the other way around. So finally, to emphasize the point, once a file is self-protected, the protection is universal across all applications, networks, cloud, and IoT platforms. So the attack surface in that situation becomes a single file independently of the applications or the platform. The economics of the attack also changes. Now the attacker needs to work on each file separately. So the resources an attacker needs to put aside scales with the number of files. This is in contrast to the non-data-centric approaches, where a successful exploitation of a vulnerability may lead to the entire set of data, all files being exfiltrated. So once the controls on data are covered, also management becomes much simpler. It can even be handled by business users rather than a dedicated IT personnel. Okay, ultimately you address the problem at the source, since much of the security is dedicated to protect the data in the first place. So let me talk about this at a deeper level, where granting access versus granting ownership, the difference between the two. Like, I mean, Tony, you have made a great point that traditional IT controls focused on like building perimeters around the data and the IT infrastructure. So the action space of these controls included like locking down networks, devices, and people, but they have failed to protect data in major ways. The main reason for the failure is that these controls get in the way and frustrate business users to the point that they intentionally find workaround. So as a result, the business users force IT to dial back the protection, resulting in nothing more than a security theater. I mean, this has been the case for almost all of the DLP users that I have seen in my experience. As I mentioned, the early zero trust architectures are geared toward controlling the activity around the data by integrating zero trust to infrastructure access controls. Now, there are two potential shortcomings of having zero trust at layers above rather than directly to the data itself. First, they do not eliminate data losses when data is taken away or stolen. So once access is granted to the data, the ownership of data is also passed on. So for example, an insider with validated credentials at the time of access can still exfiltrate data, and hence the insider problem, right? So to that end, the main promise of zero trust is broken, since you need to trust that user at that point. So let's understand this. Access is temporary. That's how you want it. However, ownership is permanent. So when access equates ownership, an organization loses data when an employee leaves, when their data is stolen, and when data is shared with the partners and so on. So a second issue is these architectures still build protection based on activity around data. In that sense, they show similarities to the old paradigm, despite removing this notion of the perimeter. But the problem is the attack surface, the overall, potential activities, encompassing identity and access management, application behavior, system controls, all that stuff make the overall security architecture highly complex. That's not what you want. You want the security architecture to be simple. In an engineering system, indeed, lack of simplicity almost always leads to lack of robustness. So if a single component here is broken or not properly calibrated, the whole solution potentially breaks. So next, I'm going to explain, the big question, right? Now, how do we build a robust solution that is data-centric and addresses the shortcomings of the previous approaches? So at Anchor, we do it by combining 3 techniques. So those 3 techniques are encryption, number 1. But the difference here is that we make encryption fully transparent to the end user experience. It is not only does it remain persistent, but despite remaining persistent, it remains fully transparent to the end user, so that as long as the end user follows the rules or meets the attributes that you are referring to, the encryption is unknown and it doesn't change any of the workflows. Another thing about transparency is that it integrates to any application, any store. You don't need to change or change the applications or take the data somewhere just to make it protected. I refer to the rules. Those are what in this slide I use as multi-factor access control. So you refer to it as attributes. So it can be, for example, specific geographies. You can say, hey, these files can only be accessed within United States of America. Or it can be specific connectivity rules. For example, it's only accessible within your company's Wi-Fi LAN. Or it can be your typical role-based access controls connected to the Active Directory. The trick here is that you don't just give access, you control it subsequently, meaning if at any given point in time, one of these rules are broken, you should still be able to revoke access after the fact. So that's very important. It's beyond access control. It's authorization, continuous authorization. And lastly, Anchor provides digital chain of custody and forensic logging continuously. So you will know who accessed which files, where, if the access is granted or denied, or if the file was edited as a result of the access being granted. And, as a result, you can meet compliance requirements and at the same time, do incident response and use those logs in forensics subsequently. So again, important thing in security is simplicity. This is atypical. It has to be simple, right? It has to be simple. And that's one of the advantages of having zero trust all the way down to the file. All you need to do is just choose locations, pick who gets access, and select how it can be accessed. This can be done from an administrative dashboard. And once you have entered all of these within the matter of, say, half an hour, including the end user training, you're good to go. So what are some of the use cases, some customer needs? This is where the last slide before the demo is focused on. So here on this slide on the left, group of hexagons, we show the type of sensitive information. our customers need protected. And on the right set of hexagons, we show the class of applications and stores for such data. So the point here is that it's pretty universal. In the middle, you can see the customer problems that Anchor would address, right? So though customers come from myriad backgrounds, they all have a common thread. So number one, they have the need to protect sensitive data such as trade secrets, M&A, commission, and salary information, create and leverage proprietary works like CAD designs or sensitive information of their customers such as banking details or PHI, even source code, right? So they need to extend this protection uniformly across all the applications in their company, not just the office applications. They also need to the protection to support the way they work, both locally and in the cloud. And lastly, our customers are usually looking to address combinations of the concerns here. So what are those concerns? Employees leaving the company and taking data with them, employees, errantly clicking on links or copying files to insecure locations, for example, Google Drive or their home computer. Our customers may be in regulated industries such as government, manufacturing, healthcare, and they're subject to, say, CMMC, NIST, ITAR, HIPAA, and they require multi-factor access. And they may be sharing sensitive content internally and externally. And even when the data is outside of their scope, they need protection. They routinely work with files covered under NDA, and they want to enforce the NDA through technical mechanisms as opposed to legislative. And concerns over ransomware is also big, specifically extortionware, which is the next generation of ransomware, is a concern. And lastly, they are trying to obtain, renew, or afford cyber insurance. So with that, I would like to, show a quick demo on the operation of Anchor. And, this is pre-recorded. So I'm going to directly share the recording with you.
This file is anchored. The security is baked directly into the file. Nothing changes for the user as long as they're following the rules. I can only access this PowerPoint if I'm following its rules. In this example, the rules are that I must be logged into our organization, I must be connected to a corporate Wi-Fi hotspot, and the file must be opened from a folder I specifically authorized called confidential files. With Anchor, the security follows the data. Because this file is anchored, it's completely encrypted. If you copy it somewhere else, the copy is encrypted too. Here, I've copied the file to my desktop. I'm still logged in, I'm still on the mobile hotspot, but the file is no longer in the authorized folder. I'm following the first two access rules, but I've broken the third, so I can't open the file. In this example, I tried to open the file from my desktop, but the same would happen if I tried to email it, upload it to the internet, or copy it to a USB thumb drive. Likewise, I couldn't open the file if I were not logged in or if I disconnected from the corporate Wi-Fi hotspot. With Anchor, companies can be confident their data is only used on their terms, following the access rules they set. Collaborating with colleagues and partners is incredibly important. File sharing happens between individuals, between groups in the company, and even with third parties outside of the company. With Anchor, you can share files however you choose and still maintain control over the content. Now I've copied the anchored file from my desktop to a network shared folder that is protected by Anchor. The file didn't change at all, but I can open it now because once again, I'm following the access rules. Sharing files with Anchor is easy. As we just saw, one way to share files is to set appropriate access rules and simply send the anchored file itself by any means you want, such as email, a network shared folder, a cloud drive, or a USB thumb drive. The file is completely unusable until it's decrypted, and it can only be decrypted by the right person under the right conditions according to its access rules. Another way to securely share files is through a web browser using Anchor's built-in web collaboration. The advantage of web sharing is that no software needs to be installed by the person you're sharing with. Simply go to the file you want to share, right-click, and choose Share with Anchor. Here I can set sharing rules that control how others can use the file. I can set an expiration date, require a password, and choose whether they can edit the file or just view it. Even if I allow them to edit, they will not be able to download an unencrypted copy of the file. I am still in control of the content. I can now just send the link by any means I want, such as email, chat, or text. My collaborators now have monitored and controlled access to the file right in their web browser. In this case, since I enabled edit access, my collaborators can edit the file right in their web browser, and I will see the changes. He or she who giveth access can taketh away. Unfortunately, that's not true with business data because it's trivial to copy. Until now. When you share files with Anchor, you can revoke that access, not just to the original file, but also to copies of the file your collaborators have made. Imagine a contractor I've hired for a project that needs temporary access to sensitive data. After the project is over, I don't want them keeping their own copies of the sensitive data I shared. All I have to do is find them in the Anchor dashboard and disable their access with a click. Now they can no longer access the files I send or any copies of those files they've made. I'm still in control of my content. What if you're the data administrator? Keeping control of your sensitive data is powerful, but it's also critical to know who, when, where, and how your sensitive data has been used. Anchor keeps track and provides incredibly detailed reports that give you a clear picture of how files have been accessed. Here, I can see exactly how this file has been used, including every time it was opened, closed, and every time access was denied or revoked. For each event, I get details such as who, when, where, and how it happened. Here I can see a bigger picture about my organization as a whole. The Anchor dashboard can easily be customized for your organization, so you get a meaningful summary of what's happening at a glance. If I want to dig in really deep, I can even download the raw monitoring data as a simple CSV file that can be imported into data analysis tools like Excel and Tableau. In addition to Anchor's built-in dashboard and reports, all of this data can automatically be fed into monitoring tools such as a System Information and Event Manager, or SIM. Let's recap. We've seen how Anchor empowers us to protect data itself, not just networks and computers, by encrypting files and enforcing powerful access rules before allowing them to be used. We've seen how Anchor enables secure collaboration, where you stay in control of your content even if others have made copies. We've seen how Anchor can revoke access to files that have already been shared and copied out of your network, and that Anchor monitors the use of your sensitive files in great detail, giving you a clear picture of exactly how they have been accessed. Anchor flips the data protection paradigm on its head, providing a better way to protect and control sensitive data, collaborate securely, and monitor sensitive data use. Anchor your data.
So this finalizes the demo. I'm going to give you the ability to share screen, Tony. And there's just one question. Let me know if you want me to address it right now, Tony, or you want to.
Yeah, go ahead. I think it makes sense to go ahead and ask.
So yeah, the question says, does Anchor could be integrated with a central decision point? How can it be interoperable with other zero trust architecture components? So that's the other value of pushing protection all the way down to the data, all the file, because it comes as an additive component, directly integrates itself to the data rather than replacing other, say, controls may or may not be zero trust nature to the to your existing architecture. So you can definitely have it additive on top of your existing architecture. And we can, I mean, the controls will be managed directly from the decision units or the administrative dashboard that you have seen. But please reach out to me if you have further or more specific questions, and we can definitely have the conversation. So another question that came in was use cases for data exchange with authorities who accepted using the solution. Okay, so there are two ways of sharing. One of them is the one that's demonstrated either directly from the desktop or directly integrated to your cloud solution, link-based or from the web. That is easy. It's automatically creating a link and sending the email notifies the authorities, and they can go through the OTP process, making sure it's indeed coming or being accessed by the appropriate person. The second is if they, when you say accepted using the solution, if they mean setting up an endpoint software to their endpoints, then it's completely seamless. You'll be collaborating with them as if they are within your organization, yet have control of the files subsequently.
Okay, so so now I can go over the NextLabs solution. So NextLabs has a unified policy engine and allows you to protect resources in like on-premises systems, in the cloud, both public and private clouds, as well as data within that's generated and stored within SaaS applications, however they're being accessed. So with our solution, the users, it's not like the identity of the person accessing is not limited to individual users, but it could also be designated as like a device, as users, as remote users, as suppliers. That is really the identity of the entity that's accessing the resource. Then and like all of our policies on our platform are identity centric, so you can define the user and their attributes as to when the policy should be applied. It allows our customers to implement the principle of least privilege access, so only providing the minimum access that is needed and the authorization required for the request. All of this using the attribute-based or ABAC policies to define what they should be able to access and when. It allows our users to secure both like applications and that data within the applications. So a key part of this is that the authorization management is externalized. So you're defining the access policies centrally, and then those can be applied to on multiple systems. Be applied to both data at rest and data on the move. So the protection stays with a file, as well as allows you to protect both structured data in databases within applications, as well as unstructured data like files. The key point here is that individuals, users can't steal what they can't see and are not allowed to access it. So by preventing them from accessing it in the first place, then they are unable to take anything that they're not supposed to take. And so yeah, there's a lot of things on here, but I think we covered most of the point. All of this is really is part of our unified policy engine and platform. So for NextLabs solutions, we divide it into different domains. So we have products for protecting data at the source. This would be whether it's in so within applications. This is the item on the left, the externalized authorization management. So it's securing the applications, securing the data within the applications, and really simplifying the process of role management and access control. We have our products for data on the move. It's protecting files and unstructured data, even as they're moved outside of applications and however they're being shared and stored. This is our enterprise digital rights management product that we call Sky DRM. And then we have our global data access product, Data Access Enforcer. And this is securing access to files, to data that's being stored within databases. So it's protecting it at the data access level, regardless of the application or the users that are accessing the file. So it's really protecting anything that's being accessed within that database and enforcing policies at the data access level when the data is being accessed. All of this is managed through our unified policy management platform, Cloud AZ. We also refer to this as the control center. And that's where you're defining the policy, like centrally defining and managing the policies, as well as essentially managing the logging and the auditing of the application of those policies. To show this all on a diagram, here we have on the right side, we have all of the sources. These are especially like sources for the attributes that are feeding into our policies. Those policies are defined and managed within our control center, Cloud AZ. Again, a central place to manage those policies. This is also where auditing can be done. Centralized auditing can be done, and logging is all done. Policies are evaluated in our policy controllers. This is done dynamically. So when at the time of the access request, and then the policies are enforced, the policy enforcement points are actually within the applications at the database layer, or for unstructured data such as files and documents. This is where we have integrations with SharePoint and other file storage products as well. Specifically, like at the policy enforcement points, I mean, that's where the request is happening. So that request is passed back to the policy controllers to evaluate, and they send back a policy decision, which is then enforced at the enforcement points. So we have a number of existing integrations with many products. This is a little bit of an eye chart, but it's showing the wide range of products that we have integrations with, both for attributes as well as for the enforcements. The applications, the databases that we have built-in integrations with. So the way this all comes together is providing the security at multiple layers. So like to emphasize that, again, all of the policies are defined, managed, audited, logged centrally with our control center. But then the policies are applied at different levels. So we have the data access security products, so DAE, which are enforcing policies at the data access layer in between any applications in the database. Our entitlement management products, where deployed within the application layer, so protecting the applications and the data within those applications. And then our EDRM product, SkyDRM, is what is used to protect data on the move. So when files leave that application, making sure that the protection goes with it. So now I'm going to show a couple of demos. Mine, again, are pre-recorded as well, but going over what we're going to see. First demo is our Windows Desktop Enforcer product. So this is showing an example of how access to files can be based on the attributes of the user and of the document. So we have users with different citizenships, as well as membership within different communities of interest, which regard what and clearances. And then they will be accessing files with different combinations of classifications, as well as communities of interest associated with it. This is really going after security compliance requirements for controlled data. So users will only be able to access the classified files for which they have the clearance to access it. They must have citizenship in one of the countries that is designated as being released to, and the releasable to on the files. And then they must be a member of all of the community of interest associated to the files. There's also an additional restriction that the community of interest file with tiger marking can only be accessed within the USA. So now I will jump over to the recorded demo. In this demonstration of NextLabs Windows Desktop Enforcer, or WDE, we will review the solution that meets the following security compliance requirements. Users can only access classified files for which they have the clearance. Users must be a citizen of at least one of the countries listed on the releasable to property of the files. Users must have qualifications for all of the communities of interest, or COI, attributes of the files. And finally, files with a COI of Tiger may only be opened while in the United States. Here you can see the list of users that we will use for this demo: Anne, Bob, Chris, and Dan. In this demo, we are using Active Directory as the identity provider. So let's look at the properties for these users. First, we'll start with Anne. Anne is a citizen of the United States, has a clearance level of top secret, and is a member of the COIs of Tiger, Lion, Bear, Bananas, and Apples. Now we'll look at the properties for Bob. Bob is a citizen of the United States, has a clearance level of secret, and is a member of the COIs of Bananas and Apples. When we look at Chris's properties, we can see that his citizenship is Canada, he has a clearance level of secret, and he's a member of Lion, Bear, and Bananas COIs. Finally, we'll look at Dan. Dan is a citizen of Canada, has a top secret clearance, and is a member of the COIs of Tiger and Apples. So in this case, a Canadian citizen has been given a secret clearance. But despite this, sample C, which is meant to be only viewed in the United States or by US citizens. So let's log in as Chris, who is a Canadian citizen with a secret clearance. He is going to be denied access to the sample C spreadsheet because the document is releasable only to the United States. Now we'll log in as Bob, who is a US citizen and also has secret clearance. Bob will be allowed to open the sample C spreadsheet because he is a US citizen. This is a requirement of the document being only releasable to the United States. So now let's look at some of the document properties. We can see that this document has a classification of secret, and it's releasable to the United States. So in many cases, restricting access based on citizenship isn't enough. In addition to citizenship, viewing classified files on foreign soil can constitute a security risk. So we'll see in this demonstration that document D is meant to be only viewed by US citizens within the United States with top secret clearance and membership in the Tiger COI. So we'll log in as Dan from a workstation that's located in Canada. Dan is a Canadian citizen with top secret clearance and a COI of Tiger, but he will be denied access to open the sample D document because the workstation is not in the United States, despite his clearance and a COI. Now we'll log in as Anne to a workstation that is located in the United States. Anne is a US citizen with top secret clearance and a COI of Tiger, so she will be able to access the file and open sample D document. Now we can look at the document properties. We can see that this document has a classification as top secret and is a COI of Tiger. Here we can see how NextLabs Windows Desktop Enforcer is used. Right, and now I have a second demo for that's showing our entitlement management manager for SMB, specifically for protecting files on AWS S3. So here we'll see that the file access control is based on user attributes, file content and properties, and the file path. And then folder access controls is based on the user attributes and the folder path. We have in this demo, examples of how these can be controlled based on the privileges. So create, view, copy and move, edit, delete. I think that given where we are on time, I'll probably just show a couple of these. Yeah, just I want to make sure that we have some time for question and answers at the end. So let me go ahead and get that as well. In this demo, we'll show the NextLabs Entitlement Manager for SMB. We'll show attribute-based access controls and dynamic authorization for AWS S3. In this architecture diagram, we see the NextLabs Control Center server. This is where dynamic authorization policies are created and managed. We also see the NextLabs Entitlement Manager for SMB. This is a server that is protecting AWS S3 and Azure files. Instead of users connecting directly to the cloud storage, they connect to the NextLabs Entitlement Manager. Here, we have mapped the SMB share directly to the AWS S3 bucket. 52.24.126.52 is my EC2 instance hosting the storage gateway. EM_SMB demo is my SMB share. Next, mapped a new SMB share to 10.2.0.7. This is my NextLabs entitlement management server that is protecting the same AWS SMB share. We will show file access control based on user attributes, file content, file properties, and the file path. We'll show folder access control based on user attributes and the folder path. File operations, in the file operations we will show the create, view, copy, move, edit, and delete. Here's a list of our Active Directory users and their department and license attributes. Our demo environment consists of 2 Windows 10 workstations, 2 Windows 2019 servers, an AWS S3 bucket, and Azure File Store. In this use case, we will restrict the ability to create folders and files in an AWS S3 bucket by using the user department attribute. Only users in the HR department will be allowed to create in the HR folder. First, we'll log in as Freddie Luddy from the development department and open the HR folder. Let's try to create a folder and a file. We can see that we're denied. Now let's log in as Carol Welch from the HR department and open the same HR folder. Again, we'll try to create a folder and a file. Here we can see that we're allowed. In the next use case, we will restrict viewing files in an AWS S3 bucket by matching the user license attribute to the document property. Only users with matching licenses are able to view files in the sales folder. First, we'll log in as Dawn Goodlife that has a user license of 1002. We'll open up the sales folder and try to open the customer 4 document. We're denied because the document license property is 1004. Now let's open the customer 2 document. In this case, we're allowed because the document license property is 1002. Now let's log in as John Patterson that has a user license of 1004. We'll open up the sales folder and try to open the customer 2 document. We're denied because the document license property is 1002. Now we'll open up the customer 4 document and we'll be allowed because the document license property is 1004. In this use case, we'll restrict a folder in an AWS S3 bucket. Okay, so in the interest of making sure that we have enough time for questions, I will go ahead and pause it. Like we have, like the demo continues to have, demonstrates like controlling other actions, but it's enforced in the same ways, where defined by the policy, the user attributes, as well as the file attributes. So, but I do want to make sure that we have time for questions. So you can ask any questions through the Zoom Q&A interface. I have a question here for how an end user might troubleshoot an issue where access is being denied, and how would they necessarily understand it. So I'll speak from the NextLabs solution perspective. You can have custom messages to the user, and this is whether it's within an application where they're accessing data, the structured data, or if it's unstructured data. You can specify the message that a user would receive, and so you can let them know to contact their IT administrator, security administrator, to be granted access if they would be allowed. So
Right. So on the Anchor side, there's an automated message that pops up describing in details what the reason for the block of access is. And when you click on it, you get more detailed explanation and also, contact to us and or the administrator location for that.
Okay. I see that we are just past 10 o'clock. And so at this point in time, since there's no other open questions, we'll wrap it up. Again, just as a reminder, this webinar has been recorded, and everyone who registered will be getting a link to the recording that they can share as soon as we have it posted online. I would like to thank Emre once again for being here for this webinar and contributing his expertise. For those of you who may not have seen it, Emre and Anchor also collaborated with NextLabs as part of our expert Q&A series on this topic. We produced a great video that you can view on our YouTube channel and through our website. So I definitely encourage everyone to see that as well, and to share that with anyone that they would find it useful. So again, once again, thanks for everyone for joining. If you have any final thoughts, you can add them, but I really appreciate everyone's taking the time to spend with us today.
Yeah, thanks, Tony. Thanks, everyone. Thanks for hosting me, and thanks for your attention. Please reach out if you have any questions or anything further. Contact information is on this slide. Looking forward to having further conversations.
All right. Thanks, everyone. All right, bye.
Thank you.